Yeah, I'm back with an update to my CNC conversion of my Grizzly G0752 lathe. This is the fourth video. The first video I detailed all the mechanical and electrical conversion and introduced the manual controls. This lathe is basically running two controllers. One is a manual control with an Arduino, and that's what's happening there. There's some encoders on the hand wheels, and the half nut's connected with a switch. So that you can just come up to the machine and do all kinds of manual operations without hooking up the CNC software at all. And then there's another controller. You can flip the controller to a Mach 4, a smooth stepper, which runs Mach 4. That's the first video. The second video, I added a function of threading to the manual aspect, to the Arduino. And the third video is profiles. So you can pick a number of points along a part, and the motors are going to go exactly where you want them to. You can do tapers, chamfers, things like that. In this last video, which is the last function I want to add, is radiuses, internal and external, and to be able to turn a ball. So I'll do the same thing as the last ones. I'll take you over the drawing, show the part that we're going to make, then come back, get tight into the part, and the DRO, go through all the input required to make this part, and then cut the part. Alright. These are some of the test parts that I've been doing. Just simple internal and external radii arcs. This is the part we'll actually do right now. I did a little test part in wood. So this function, the input by the operator, is not as intuitive as the threading and the profiling. They were pretty simple and basic. It walked you right through the dimensions needed to be input to the DRO. But this one's a little bit odd. On the top here, you'll see this is generally what you'd see on a drawing. These got all the dimensions of the part we want to make. It's going to be a 28 millimeter ball on the end. 10 millimeter shaft coming out here with an internal radius of 8 millimeters. Now we're going to have to do, this is actually three functions. There's two external radius and then an internal radius with a profile here. The pictures below here, the external one and the internal one, show kind of what the dimensions are that I'm going to need for the DRO input. I'm going to set my axis and zero out my z-axis right here, which is right at the internal radius face. I'm going to use a 10 millimeter round insert. So that's what's shown in these dashed lines here. And these are basically the positions that the LCD display, the DRO, with the inputs, it's going to be asking for. With the 0 here, on this external face right here, on this first external radius, the program asks to go on a tangent. It basically asks the tangent first, the face that you want to do, and then it asks to move to the center of the part, the center of the radius. And then on this external one, we're going to be setting the face right here on the internal portion, and then it's going to ask to choose the radius of that one. It's also going to ask the outside diameter that you want the ball to be. For the external on the far side, these are the two numbers that I'll be inputting, and on the external on the inside, these two numbers. The inside has a restriction, a 10 millimeter diameter restriction here, and in the program it'll ask for that if you want to put that option in. So we'll do that for that one. Alright, let's cut the part. So our part's ready to go now. This is my 0-0 position. To get into the function, just like everything else, you press and hold the third button. Brings you into a mode selection. We have standard feed, brings you back. External threads, internal threads, which I still haven't gotten to. Profile taper, and then now we're going to do the radius sphere function. So I'm going to choose this. First question is the arc type. We're going to choose internal or external. On this, we're going to do the outside external radius first. It's asking for the insert type. You have round and then basically everything else, diamond, but anything with a point. We're going to choose round. I'm using a 10 millimeter. It defaults to the size. You can of course change the size. We're going to choose 10. Next question. Move the x-axis. Touch any outside diameter. And then you have to enter the measured outside diameter. Well, I've already done this. My tool is touching the outside diameter, and the measurement is 30 millimeters. So we're going to go ahead and dial in 30. And choose OK. Now, what this does is it simply tells the Arduino program where the center axis is of this part. It's touching the tools on the diameter, and we're telling it what the diameter is. Next question is to move the z-axis and to set the tool on the face tangent to the arc. So on this external arc, it's the one all the way on the outside, we want to set our tool right to the tangent. And in this case, I've left some extra material right off the part. Now it says to move the x-axis, set the tool on the maximum stock outside diameter to cut. Now, I'm at my 30, I know that's the max diameter, so I'm just going to say accept here. But if you had more material out here, you would be moving your x-axis outside. Now we're moving the z-axis, and we're going to put the tool center to the radius center. That's what it wants. So the center of my tool, and it's telling us what the radius is. And we know the radius we want is 14, so I'm just going to dial it to 14. And also it tells you where the axis is. It's at 29. When I check the print, the dimensions I have in there, that's correct. I'm supposed to be at 29, and my radius is supposed to be 14. So I'm going to accept. Now we're choosing the max diameter at arc start. So the ball diameter is 28 millimeters. And that's what it's looking for. It's looking for the maximum arc. So I'm going to set this to 28. Now with a 14 millimeter radius, this is going to give us a ball. If I set it to 30 millimeters here, we'd have not quite a ball. There'd be a 4 millimeter landing there. So we're going to accept the 28. Now it's asking for extensions to the radius. The radius is known now. The entire profile is known. Now it's asking if you want to keep profiling along this arc out here. And I don't want to. That's fine where I stop. So I'm going to say none. And it also allows you to choose a facing operation to extend the face. I'm going to choose none. Create the dumbbell diameter. This will go through on the other side when we're doing the inside of the arc here. To finish off the ball, we're going to have to stop the diameter short here. And that's what the dumbbell is. I'm going to choose none on this one. Roughing depth of cut, I'm going to dial this back. It's going to take us more passes to go through. But my speeds and feeds I don't have fine-tuned just yet, so I'm going to take it a bit easy on this. So 0.4 millimeters for a rough cut, depth of cut for the finish is the next question, and that's 10 or 100 microns, that's fine. Now we're going to set the RPM. That's going to lock in the 6 inches per minute. And it's asking to engage, radius is ready, engage the half nut. This will start cutting the radius now. it's telling me I have 51 passes, so it's going to take a bit. It gets really slow at the end, right at the apex of the diameter, and you'll see that it slows down. So we'll speed up the video. So after the last pass, it'll ask me to toggle the half nut again for a finish pass, and that'll be our 100 microns that we entered in. And let's re-engage the half nut for the finish. That was taking a bit of material out there. Alright, we're ready for the finish. Toggle the half nut again. Should be taking 100 microns. Now that's a very good match on the diameter. This time we're going to do the internal radius, the last operation we're going to do. Again, it's the round insert. We won't change insert. It's 10, and it's asking again for outside diameter. Now I know I'm on a 30 millimeter diameter, so I'll dial that in. So we're at 30 outside diameter. This just tells us where the stock center line is. Set tool on the face tangent. Now I know actually when I'm at 0, that's that's the position I want on this one. So I'm tangent to the face now. This tool on this on the face. Stock maximum outside diameter. There's no extra stock beyond 30, so I could just choose OK here. Tool center to radius center. So now I'm moving my tool to the radius center, and we can see the radius is moving. When I was back at the 0 point, the radius was 5 millimeters. That's the smallest radius I can do with this insert, because it's a 10 diameter. So as I move my z-axis, you can see the radius following along. So we're going to go to 8 millimeters is our radius, and we're going to accept. It's asking for the minimum diameter at the arc finish. So that's after the arc finishes up, what diameter is in here, and that is the 10 millimeter diameter. So we're going to dial that down to 10. And I'm actually not going to, what I'm going to do is I'm going to increase this so I'm oversized. So what I'm going to do is I'm not going to cut it 10, I'm going to cut it 10.6. So there will be a step here, and we'll be able to visually see that step 0.3 off on each side, and then we'll be able to adjust it afterwards, just so I can show that feature. So diameter 10.6, we're going to accept that. Now this time I want an extension. I want to continue this arc from this position, and I want to continue a profile until I match up here. I'm not going to go right to the ball position. I know the ball position would be a 9.8 millimeter extension. I'm going to go slightly less than that, so I'm going to go about 9.5, let's say. And this is a dialed in number. So 9.5. So that's going to stop short of touching the ball. A facing operation? No, we don't have any external facing since there's none. So it's 600 and 100 for the depth of cut finish. I'll dial in the feed rate. I'll actually even go heavier on the feed rate here, see what happens. Accept. Now we're engaging the half nut. First operation is it goes to the beginning of the operation. And now it's saying to toggle again, and we'll start cutting. I fine-tuned the internal radius motion a little bit better, so we don't hear as much chatter. That could be a potential problem. But I've got no pause on this. Alright, well, we didn't see that very well, but so now it's asking for the finish pass. This is taking 100. And now we can see that step right here where they don't match. That's because I put in a diameter 10.6 here, and this was coming down at a diameter 10. So there should be a 0.3 infeed that I need to adjust for. Let me just take a quick measurement. The previous diameter is right on 10, and 10.7. So it needs 350 microns of infeed to adjust. I'm going to go 300 and then take a measurement. So I'm not going to exit this operation. I'm going to choose adjust radius position. Now it's asking if I want to left radius, shift the radius left, so I can move this radius back. I'm not going to do that, so I'm going to say none. And now cut radius deeper, the offset. And actually this should say infeed, because that's what I want to dial in, the infeed. So I'm going to dial in 300 microns. Wow, 300. We're going to accept. Toggle half nut again. I was taking, depth of cut is the same, 600 and 100 is the finish. Wow, that looks pretty good. Now by feel, there's absolutely nothing there. But you can creep up on it by microns if you wanted to. I think that's finished. That's not too bad. Take some measurements. That was supposed to be 28. There's a little smudge on my caliper, but that is a 5. So we're 50 microns over. The inside is supposed to be at 10. That's a 9, so we are still a little bit heavy on that. And well, that's about all the dimensions I'm going to do. I'll have to get a little radius gauge out and see how that looks. But the ball it's got a perfect, see, there's just nothing there. Same with the tip.